Hello there, everybody. This video is about a new transformation called a dilation. Now, we've done some stuff with transformations before. We've done reflections where you flip something over. We've done rotations where you turn something. We've done translations where you just translate it, you slide it. There's one more, and it's called a dilation. Kind of like when your pupils dilate, they get bigger. A dilation makes an object bigger or smaller. It stays the same shape, but again, it just gets either bigger or smaller, depending on what we call the scale factor. I'm going to show you how that works. Just like rotations have a center, kind of a point that you're rotating a figure around, dilation, there's a center of dilation too, and it's just kind of a point that you count from when you're doing the dilation. In this case, we're going to say that the point 0, 0 is the center of dilation. Little arrow there. So again, we're going to say the center of dilation is the origin, or the point 0, 0. And that's just the point that we count from. So we're going to dilate this, this quadrilateral, this four-sided shape, ABCD. And we're going to do it with a scale factor of 2. Okay, so the scale factor is 2. We could use any scale factor we wanted, and the rest of this learning activity has you do some other scale factors, and you'll see what happens there. I'm going to do scale factor 2. We could do 3, 4, 5, 8, 100, 0.5, 0.4, anything we wanted. For now, we're going to go with 2. Okay, so the center of dilation, again, is the point that you count from. So to get to A, we've got to go over 3 and up 2. Okay. We all can see that. So when we dilate it with a scale factor of 2, you go twice as far. So instead of going over 3, we go over twice as far. We go over 6. 2 times 3 is 6. Instead of going up 2, you go up twice as far. So you go up 4. And there is your point where A ends up after you dilate this thing. So again, instead of going over 3 and up 2, you go twice as far. Over 6, up 4. So to get to B, we got to go over 1 and up 2. But since we're doing it with a scale factor of 2, we're going to go twice as far. So not over 1, but over twice as far would be 2. And not up 2, but up 2 times 2, which is 4. So there is where point B ends up when you dilate this figure. C, we got to go over 2 and down 2. So we're going to go twice as far. Instead of over 2, we're going to go over 4. Instead of down 2, we're going to go down 4. And there is where our point C ends up. Now, point D, we got to go over 1 and down 2. So we're going to go twice as far. That's what our scale factor is. It's 2, so that's why we're going twice as far. So instead of over 1, we're going to go over 2. Instead of down 2, we go down 4. And there's where D ends up. And now, if we connect the dots, which I'll attempt to do here in a second. Oops, what happened here? There we go. There's one of those. Those lines. There is another line. Another one here. There we go. We have one more to go here. Whoopsie daisy. Didn't want to do that. Yep. That's okay. And so there is our dilated shape. So again, we went twice as far because our scale factor is 2. When you go, if you were doing a scale factor or a zoom, also called a zoom factor, of 3, you'd go 3 times as far. And our scale factor is 2, so we didn't go over 3 and up 2. We went twice as far. 2 times 3 is 6, and 2 times 2 is 4. So we went over 6 and up 4. You're just doubling each number. If you went with a scale factor of a half, you'd go half as far. So you'd go over half a 3 and up half a 2. So whatever the scale factor is, that tells you how far to go. But always, 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 in this case, we were counting from the origin, and that's that center of dilation. That's that point that you count from. Okay, continue on with the rest of the learning activity. Hope this makes sense. If it doesn't, be sure to get some help. See you soon. Bye.